Hello, hello, hello. A big, warm welcome to each one of you who just tuned in. A big hello from India, Kolkata. My name is Gaurav Tekriwal, and I represent my organization, the Vedic Maths Forum India. It's a pleasure that all of you have joined us today from all across the world. And today we have a very special guest. But before I go on about him, I would like you to say hello if you're watching and just type in your city name so that I know where you're from. So, welcome to all our guests from Facebook, Twitter, Instagram, and even YouTube. A big welcome. Today, we are privileged and honored to have Professor Arthur Benjamin, who is an author, TED speaker, and America's fastest maths whiz. So, before I would like to go on with the bio, I would like to say big hi and warm welcome, sir, to our show.
Thank you, Gaurav. It's very nice to be here.
I'd like to share professors little bit about the Professor Benjamin. So, Professor Benjamin is an American distinguished mathematician who specializes in combinatorics. Since 1989, he has been a professor of mathematics at Harvard College, where he is the Smallwood Family Professor of Mathematics. He is known worldwide, I repeat, worldwide for mental math capabilities and mathematic performance in front of live audiences. His mathematical abilities have been highlighted in newspapers and magazine articles globally, at TED Talks, and on the Colbert Report. A big warm welcome, sir, to our show. So I would like to ask you
Thank you.
the first question is, sir, how did it all begin for you? How were the early days like?
I think I have always loved numbers for as long as I can remember, for as long as my parents could remember. Numbers and I just always got along. And I think what I enjoyed most was that you could take mathematical problems and you could solve them lots and lots of different ways. And if you were careful, you would always get the same answer. And I just found that consistency of mathematics to be absolutely beautiful then, and I still do now, today.
Wow. Math is your always been a passion, as you said. So who inspired you? Because in our traditional society, math is always looked down upon. I mean, students especially loves to hate it. So how come you got into maths and who inspired you and how?
I think the numbers, the mathematics inspired me just by themselves, but I certainly have a lot of gratitude for my parents who saw that I had an interest and a passion, and they nourished that passion. I had some very patient teachers, and I say patient because though I was good at math, I was also quite the handful. I was a hyperactive child, having trouble sitting still and just very energetic. And so the fact that I was able to, that they had the patience to deal with me, I think was very important.
Wow. So that led to your career, and I mean, we are privileged to know that you have authored over 100 research papers and presentations. Tell us more about your work, Professor. Tell us more about that.
Well, I'm a professor of mathematics at Harvey Mudd College in Claremont, California. And the research that I do, some of the research has to do with combinatorics, which is the mathematics of counting. And a lot of the research involves the Fibonacci numbers, my favorite number system, and understanding all the beautiful patterns that those numbers possess. I'm presently the president of the Fibonacci Association, which is an international
Ah,
organization to study and appreciate those numbers. I also have an interest in mathematics of games and puzzles, and some of my research involves things like how to play certain games in the optimal way. Personally, my favorite game is Backgammon. Anybody who loves mathematics should investigate Backgammon because a little bit of math goes a very long way. Gosh, so for me, the writing papers is great fun. And I guess that one of the points I want the audience to know is mental math is just the starting point. It is not the end point. And being good at doing math in your head is great for getting started in mathematics. But if you really want to go far and use mathematics in your daily work, then you have to go beyond arithmetic. You have to do algebra, geometry, calculus, statistics. And if you understand those things, you'll do very well.
Wow. So I'll take a moment here to say a big hello again to all our viewers who's logged in from all across the world. First up, we have Mr. Shahid Rana, and he just messaged us saying, "What a great morning for me. Two legends live. Wow, wow, love from Pakistan." So, a big warm welcome again, sir. And then we have Madhuma Banerjee, who's wishing us good morning. And Prachi Mittal says hello. So, guys, keep on your questions coming in. And if you want to ask Professor any questions relating to mathematics or mental mathematics, keep those questions coming in. And we'd love to ask Professor about them. So, Professor, how did mathematics happen? I mean, that is something which we share the common bond with. Also, tell us about
Yeah.
your abilities.
Well, so as I mentioned before, I had a passion for mathematics, but I also, from a very early age, had a passion for magic and trying to, entertaining people with magic tricks. And when I was in high school, I did magic shows for children's parties. Nothing to do with mathematics, just your traditional magic tricks that would make the kids laugh. And as I started doing shows for older audiences, my father suggested that some of the math talent that I had developed, he said, I think that's just as impressive as the magic tricks. Why don't you do some of that? And I gave it a try, and much to my surprise, it's what everybody liked the most. And I said,
Wow.
wow, great. If they liked that, imagine what would happen if I did bigger problems and did them faster. And one thing led to another, and next thing you know, people are writing about it and getting on television, and it was great fun. And I still find it fun today. Would you like a small demonstration? May I
Oh,
give you
absolutely.
a taste of what I
Absolutely.
do? So you
Sure.
have a calculator, Gaurav. So get us started. Give me a two-digit number, any two-digit number, please.
Let's do 57,
57, and another two-digit number.
23.
Did you say 23?
Yes.
So multiply 50. Okay, so multiply 57 times 23. You should get 1,311.
Wow. Wow. I just
All
calculated
right.
that.
Now my
Wow.
now my specialty is squaring numbers. That is taking numbers times themselves. Like 5 squared is 25, of course. Let me square some numbers, and I will try and do these even faster. As a warm-up problem, give us a two-digit number, just any two-digit number.
98.
98 squared is 9,604, and you know how to do
Wow.
that very well yourself. Let's try a three-digit number. Give me a three-digit number this time.
How about 456 squared?
That's 207,936. That
Wow.
was a pretty quick one. Let me try
Wow.
another one. I might not be as fast, but give me another three-digit number.
How about 124 squared?
That's 15,376.
Oh my God, that was
Let me
quick.
try. Let me try a four-digit number. Now, I will not be as fast. I will not beat the calculators. I will try to get it right. And just to make it a little easier for us to remember, I will write the four-digit number on the board. So give us a four-digit number this time.
1, 2, 3, 4 squared.
Okay. That is equal to 1,522,756.
Wow. You just wrote it like that. Wow.
Easy as one, two, three. um, so anyway, so that's a sample of what I do.
So how did you develop these abilities over time, or is it inborn talent which you had? How did these abilities come to you, sir?
Well, it was not something that, I mean, it wasn't something that I was born with. I don't think anybody is born with this kind of talent. As you know, mental mathematics is a skill, and if you practice it, you everyone can get very good at it. Um, and for me, it was just great fun to practice doing these calculations, but I was not doing them the same way it was taught to us in school. For
Hmm.
example, when I calculate, I do all of my calculations from left to right. On paper, you might do it from right to left, but it's more natural to work from left to right. That is, because we read numbers left to right, we pronounce numbers left to right, and with a little practice, you can calculate left to right. Also, it's more important to know the answer in the left than on the right. If you just have to estimate this answer, it's better to know that your answer is a little bit bigger than 1.5 million than to know that it ends in 6. So why work from right to left where you're getting all the unimportant numbers first? If you work from left to right, you can just estimate your answer. In fact, the reason I started doing it left to right when I was a kid was I found that I could start to say my answer while I'm still calculating the rest of my answer, right? Um, so anyway, so that's I can go into more details, but that's how it began.
Uh, After you just gave us those whopping answers to those questions, I mean, the chat has just exploded suddenly. I mean, a lot of questions coming in, especially I want to highlight Annapurna Sarangi, big fan of Arthur, sir. This is all love from India, and to you, sir. Dipanshu Kumar, Prachi Mittal just says, big fan of Arthur, sir, love from India. Uh, Give me some trick. And then Priyanka Tiwari says, can you teach some easy way to calculate perimeter and area of a rectilinear figure? We'll keep that for
Mm.
later.
Mm. I don't have any mental methods for doing that. Just patience and being careful is best I can say about doing that kind of problem. So, um,
Wow.
I mean, I
The
enjoy those
Ashas,
kinds of problems, but I don't have mental shortcuts for areas of rectilinear figures. Maybe someday.
of course. The
Um,
Asha asks you a question. What is 4, 5, 6, 7 squared? So we're gonna come to that.
right, right, right. I
And
can say instantly it's a little bit more than 20 million, 20, 21 million. To get it exactly, I'd have to go through the same um, process, but it's a little bit less than 21 million.
super. Somebody,
Yeah.
Priyanka Tiwari again asked me, is for class 5. And then there's a lot of questions coming in, so I want to keep that for later. But let's focus on your first book. I mean, you compiled your first book, which was Secrets of Mental Maths. I want to put it up for everybody to see. You
Yep.
partnered with Michael Shermer, and tell us about how did
Mm-hmm.
it all happen. You compiled all of your secrets in one book. Tell us about that.
Yeah, I had ever since I was a college student, I thought it would be great to share my secrets. Secrets is a bad word. I mean, as a magician, we keep secrets, right? But as a mathematician, we share secrets. We want everyone to know. And with mathematics, should have no secrets. Everybody should know how to do mathematics. And I thought because I'd never seen my techniques taught anywhere before, I thought it would be valuable to write a book that would describe them all. Um, and I'm Michael Shermer, who also has his PhD. He received his PhD at the institution right next door to mine. And we met on campus one day, almost by accident, and we got into some nice conversations. We saw we had mutual interests. He was also interested in promoting science and mathematics, and we decided to do this book together. Michael had a lot of experience with writing books, and I just had a lot of good ideas. So I think without Michael, I might never have put in the time to get to put all those ideas together. So it was a good partnership.
And I tell you, the book was a hit in India, and all mental math enthusiasts and people who appear for competitive examinations have your book as the number one book they refer to. So I must tell you that. Yes.
Wow.
Yeah.
Wow, that's really nice to hear. I'm so grateful to know that it has had such a positive influence on people throughout the world. It's a dream come true.
So let's talk about his second book, The Magic of Math. And
Yeah.
you want to add something about that?
And
How did it all
you
come
always have
about?
to say the subtitle, which is solving for X and figuring out Y,
Why?
right? Because mathematics is not just doing calculations. And in the magic of math, we go from arithmetic, which is really what the secrets of mental math is about, arithmetic in your head, to doing higher level mathematics classes, the mathematics that you will see in high school, things like algebra and geometry, trigonometry, calculus, imaginary numbers, uh, uh, exponential functions, even a little bit of combinatorics. The Fibonacci numbers, of course, have to be represented. So I wrote a book that I would have liked to have seen that shows not only the important essentials of each of those subjects, but what makes them fun and what makes them beautiful. So I had a lot of fun writing that.
Wow. So your videos have enthralled the world completely. I must see that. Your
Oh, thank you.
five video courses are the great courses. They're lovely.
Mm-hmm.
How did it happen?
Oh,
How did
thank
the
you.
ideas come in?
Gosh, the great courses goes around the country looking for professors who are known to be talented teachers, and they asked if I would be willing to audition to to put together a course for them. So I did, and they liked me, and they said, yes, we would like you to do a course. And the first course they asked me to do was on the joy of mathematics, which was a lot of the sorts of things that you see in the Magic of Math book. It was again, it was about algebra and numbers and geometry and calculus, and it was a lot of fun to do. And after that, they had me do a more advanced course on discrete mathematics, which is actually the subject that I do most of my research and teaching in. That involved combinatorics and number theory and graph theory. That was followed by my course on the secrets of mental math, which was one of their most popular video courses, and where I got to share my secrets, but on video. I then did a course on the mathematics of games and puzzles, everything from how to count cards in games like 21 blackjack to find how to solve a Rubik's cube, and how to play games like chess and especially backgammon, which will using mathematical ideas. And my very last course, which came out just 3 years ago, was on mathematics and magic. So it was 12 lessons on using mathematics to perform some amazing magic tricks, whether they be tricks with numbers or cards or geometry. It was great fun.
Your passion for numbers is coming out, sir, and I can feel me getting goosebumps because both of us share the same
Oh,
wavelength, same frequency. So it's amazing to know that.
absolutely.
So you're given three TED Talks, which has over 20 million views. So out of your talk, and you give it, of course, so many TEDx talks as well. Which is your own favorite TED talk given by you?
Gosh, they were all fun. I mean, the first one I did is the one I think that's gotten the most views. That was where I was performing the mathematical magic, the mental math, and that I mean, I had been doing it for, I guess, gosh, about over 20 years. And then when it was presented as a TED Talk at the end of 2007, just all kinds of interest. There was all kinds of interest in it. That's how my book got republished. And I did not know when I gave that talk that it would be eventually viewed by millions and millions of people. So when I did my second and third TED talk, even though I rehearsed them a lot, I was very, very nervous. The one of them was a very short 2 minute, 3 minute talk on why people should study statistics more often. That calculus is not the most important subject for students to see in mathematics. In my opinion, it's statistics, and this is even more true today than it was in 2000 and oh gosh, when was it? 2009 when I gave that talk. It's it now in the age of data science and information, being comfortable with the ideas of randomness and statistics and data analysis is so important. And so if your audience comes away with anything, after you learn how to do mental math and really get excited about math, make sure you study statistics. Then my most recent talk was on the magic of the Fibonacci numbers and what makes them fun and amazing. And so those were all great fun to give. So I can't. It's like picking a favorite child. I can't do that. They were all great experiences. All I could say is I just got more and more nervous as I gave them because I knew how many people would be watching it. It's not just performing for a few hundred people in front of you. This was potentially millions of people. So I definitely got a little nervous on the last two
And
talks.
I just want to add, sir, and with those talks, you have changed the world. You have had a
Oh,
very,
thank you.
very positive
Oh,
impact on mathematics education. Because what I see is, I want to add something that where I see it from is because the whole world is in a math crisis in terms of people don't like
mm.
maths, and we need to,
Oh.
as mathematicians, we need to spread the love for maths, and that's what you've been doing.
There are two reasons to do that. There's the first reason is mathematics is once you see it, it is such a beautiful and exciting subject. It's like it would be as if you never experienced music. It'd be like it would be just a real shame if it just wasn't part of your life in some way. But for perhaps more practical reasons, mathematics is the most useful subject, especially if you're watching this, if you're still in school and you still have your education in front of you. Nothing opens more doors professionally than than your ability to do mathematics. And I mean, people who study mathematics in college, at universities, they can go on to law school and medical school and business school and science and engineering and, of course, computer science and robotics. Mathematics is just at the heart of everything. Even mathematics trains you to think logically and critically. I mean, that's what they want. When the reason medical schools and law schools want students who understand mathematics is not because they're going to be doing calculus in the courtroom, but because they have the ability to really think carefully and solve problems. And so the more the more mathematical training you have, the more it will pay off. So, um, in there are other aspects of life where you could be very, very talented and never benefit from it professionally. You could be a very talented artist or actor or athlete, and only the very, very few are able to make it professionally. But if you're talented in mathematics or science or computer science, you will always be in demand. You will always be able to use those skills. So uh, learn your mathematics, and you'll be paid off, not just financially, but I hope spiritually and emotionally as well.
Wow. So time for some questions from audiences. But before I go on to this question, I want to give a warm welcome to all those tuning in from various social media channels. Warm welcome. Today we have Professor Arthur Benjamin with us from the United States, and he's an author, he's a TED Talk speaker, and a celebrated and distinguished mathematician from the United States. So we have some questions which is coming up. This is from Priyanka Tiwari. Oh no, I have put that again. This is from Shahid Rana, give us one advice to become an expert like you.
Well, as I said before, well, all right. It, Mathematics is hard. I mean, at some point, everybody reaches a point where you just say, this is hard. I can't do this, or I'm struggling to solve these problems. And my answer to that is don't give up. Just, work at it and don't be afraid to ask for help. Talk to your teachers, find a tutor. Sometimes you might say, yes, but my teacher is terrible. I don't like my teacher. That my teacher makes me hate mathematics. And to that I say, well, don't let that teacher ruin the rest of your life. Don't give that teacher that power. It's bad enough that you have one bad year with that teacher, but you have to go beyond that and still persist and learn your mathematics, because it will benefit you so much in the long run. Um, if you want to become an expert in doing mental math, then learn, read my book on Secrets of Mental Math. Listen to Gaurav and the Vedic mathematics that he teaches. I mean, all of this is. I did not. Gaurav did not have the benefit of this information taught so clearly when we were growing up, right? So, our hope is that we can make that path so much easier for everyone else going forward.
Anupama says, I have read your book, The Magic of Math, Brilliant Techniques.
Thank you very much. It means a lot to me.
Some tips to handle kids when they get irritated when they don't get an answers.
Yeah. A common frustration is a lot of students who try and do that all in their head. And I mean, I love doing math in my head, but it's also very important to learn how to explain your work, to show your work. Ultimately, in the professional world, they are paying you not so much for your answers, but for your explanations. Can you convince us that this is the right solution? So sometimes when students get frustrated that they don't know an answer, sometimes if you write things down, try what if you can't solve a hard problem, maybe take a step back. Maybe there's an easier problem that you can solve, and then build on that easy problem to get to the harder problem. So.
Last technical question from Shovik Shah. Can you tell us some real life example of Fibonacci numbers?
Hmm. Well, okay. The Fibonacci numbers are sometimes called nature's numbers because they show up in nature a lot. If you look at so first of all, for the audience, what are the Fibonacci numbers? The Fibonacci numbers are as easy as 1 plus 1. 1 plus 1 is 2. And then we add 1 plus 2 to get 3. And then 2 plus 3 is 5. Then 3 plus 5 is 8. 5 plus 8 is 13, and so on. And in leapfrog fashion, they go on forever. And the reason they're called nature's numbers is these numbers actually show up in nature surprisingly often. For example, the number of petals on a flower. All right. You can see flowers that have 2 petals, 3, 5, 8. You don't see too many flowers with 4 petals, right? If you look at a sunflower and you count the spirals that go in one direction, that tends to be a Fibonacci number. And if you look at the spirals in the other direction, that's another Fibonacci number. And if you add the two together, you get the next Fibonacci number. But personally, why I like the Fibonacci numbers, I mean, you can use them to solve problems, and I've seen them used in various mathematical courses. But I think they're just fun because of all the sort of magical properties that they have as numbers. And you'll have I'm not going to go into that right here. So you'll have to watch my TED Talk. If you search on the magic of Fibonacci numbers, you'll see the TED Talk. It's only 6 minutes long, so I think you'll enjoy it.
Super.
Also, there are other great resources out there on the web. There's a group called Numberphile. That's a number, Phile. They have these marvelous videos that will make you fall in love with mathematics. And some of it's easy, some of it's hard, some of it is hilariously funny. So I encourage you to look those up too.
Thank you. So, Professor, you are the best 300 professors in the world according to the Princeton Review, and you won several
Only
awards.
one editor's opinion. That doesn't.
Which one is the most closest to your heart, Professor? Out of the so many awards.
You know, a couple years ago, the Joint Policy Board for Mathematics, this is a national U.S. organization. Each year they give an award for communication of mathematics, and it was, I think it was 3 years ago that I received the communication awards from the Joint Policy Board for Mathematics, and some of the people who got it before me were some of my mathematical heroes and great communicators of mathematics. So that's really what I've always wanted to do since I went to college, was find a way to bring mathematics to the masses so other people would enjoy it like I do.
What are your thoughts about the
Oh,
Indian Vedic?
I did have one recent award. I have to mention this one because, as I said, I like things besides mathematics, and my favorite game to play is backgammon. And last year there was a series of tournaments called the American Backgammon Tour, and they had to play them
Uh,
online this year because of the pandemic. And I ended up winning the year for having the most tournament victories, and I end up getting
wow,
on the front cover of the magazine, of the primetime backgammon magazine, the U.S. Backgammon Federation's magazine. So anyway, that
wow,
was my most recent claim to fame, and I was very happy about that.
wow. That's something very
And
inspiring
and
and
and, and as
encouraging.
I said before, backgammon is the ultimate math game where a little bit of math goes such a long way. So those of you that have never played the game before, look into it, and I think you'll find it to be very, very fun and interesting.
Super, super. So, what are your thoughts on the Indian Vedic mathematics?
You know, I had encountered the old Vedic mathematics book when I was in graduate school. One of my professors, who was from India, Professor Rao Kosaraju, said, "I have this book, and I know you have this interest and talent in mental calculation, and maybe you would find it interesting." And it was hard to understand. It was written in a very, almost biblical language, not really written like a mathematics book. Um, and but over the years, I learned that a lot of the techniques that I've developed are very similar to the techniques that are in this Vedic mathematics, and other people have since written about the Vedic mathematics in ways that are clearer. I mean, I learned, Gaurav, from one of your courses about a way of doing mental division of two-digit numbers that I had never seen before, and I thought that was very, very interesting. One of my former students showed me a great way of doing square roots using something called the duplex method, which I thought was also very, very interesting. So, there's and some of the things I've just and if you get my video course on the secrets of mental math. It's not in the book, but it's in the video course. I have one lesson on Vedic division. Okay, so
Ah,
because I just thought that was really a nice a nice method that I hadn't seen before that I wanted to share with the audience, because anyway, so it's um, anyway, but I want to say, uh, the mental math, the Vedic math, is a great place to start, but it is not all of mathematics. It's just a way,
true.
I hope, to get people excited about math and then use that to later on study serious mathematics, that's algebra and probability and statistics and calculus. And there are shortcuts that you'll learn in the Vedic courses for doing algebra and calculus, but you're not going to learn to really understand those courses. You have to really take those courses. But shortcuts can make any subject more fun.
Absolutely. My second last question to you, Professor, is what do you say to people who ask if mental math is relevant in today's digital age? You must be getting
Well,
this all the
my
time, I
answer to
think.
that, my answer to that is, I think mental math is much more relevant than pencil and paper math, because it's true. I cannot remember the last time I had to multiply 3-digit numbers on paper. Maybe I had to do that when I was 10 years old, right? But not in any real adult situation. If I need to multiply 3-digit numbers or bigger, well, then I'll pull out my calculator and quickly get the answer. But if I want to get a good estimate of the answer, if I want to get a good feel for what the answer should be, then the mental mathematics comes into play. I think it's more important to be comfortable at doing mental estimation than it is to do exact long paper and pencil calculations. So I think having a brain and the ability to solve problems and being able to come up with a general estimate of how numbers should work out, I think that will never go out of fashion.
Absolutely, certainly. I completely agree to that. Because a lot of times people ask, what is the relevance of Vedic math? What is the relevance of mental maths? I already have an Excel sheet. I already have a digital calculator. Why should I go for such a
Yeah.
course? So your answer to them was
Well,
very apt.
and I have found that when I give presentations to audiences, to whether schools or teachers or other mathematicians, that that it often it just makes people more excited about mathematics. I mean, I think it's a good entry point for getting for being introduced to the world of mathematics. I mean, it's very empowering if you can do mathematics in your head. And again, it's a starting point, but eventually you move on, you know. And
Absolutely.
that's the
So,
magic of mathematics.
totally, totally. Your message, my last question to you, Professor, is your message to students and teachers across the world.
Mathematics is magical.
Oh, wow. So
And don't give up. Persist. It's worth it.
super, super. So, on that note, we have come to the end of the show today, everybody. I want to say a big, big thank you to Professor Benjamin for taking out valuable time out of his busy schedule to address all of us today and take all questions. And last comment we have from Shahid Rana.
Right.
Okay. So he said, I'm going to learn backgammon now. So that's something which is just
Yes. Congratulations. Please do. Maybe we'll play online someday.
absolutely, absolutely. So here's the link to Professor Arthur Benjamin's website. It's arthurbenjamin.info, arthurbenjamin.info. Please go to that site and get those books if you still haven't. Watch those TED Talks and the video courses, and I'm sure you're gonna get ahead in mathematics. I want to say a big, big thank you from Vedic Math Forum India. Thank you for honoring us, sir, today. It's been a privilege to have you, and I look forward to collaborating with you shortly. So,
My
friends,
pleasure.
so in the next show, which is on the 18th of March, we are having Professor Himanshu Thaplial, who's going to talk about from the University of Kentucky. He's going to talk about applications of Vedic mathematics in information technology. So that is something which we all should look forward to. Thanks once again. Please like, share, and subscribe to our channels. And I wish you all the very best. So thank you. Signing off. This is Gaurav Tekriwal, making math fun. Thank you.
Thank you.